I am Yulin Hswen, Associate Editor of JAMA and JAMA Plus AI, and you are listening to JAMA Plus AI Conversations. Today, I'm joined by Dr. David Wu, who is a resident physician in the Harvard Combined Dermatology Program at Mass General Brigham, and Dr. Adam Rodman, who is a general internist and the director of AI programs at the Carl J. Shapiro Institute for Research and Education. Welcome.
Great to be here.
Yeah, thank you so much for having us.
Oh, yes, absolutely. I'm very excited. So I'd like to start off a little bit talking about your different backgrounds, especially you, David. In your realm, you have a background in computer science and clinical medicine. And so why don't we start there as kind of how you're melding both worlds together?
Yeah, definitely. So as you mentioned, I'm a resident in the Harvard Dermatology Program. Before that, I was at UCSF and did my MD, PhD. And so I did a PhD focused, I wouldn't say necessarily on computer science strictly, but on a lot of computer science and data science techniques, large-scale data analysis, genomics, transcriptomics. When I became a clinician and started seeing patients in the hospital, including during my intern year, which was an internal medicine year, started realizing that there were so many things that were happening in the hospital and in clinics that could also benefit from this rather than just me looking at genes and molecules and analyzing those. So I started just thinking about how to meld those two together, and kind of clinical informatics and now medical AI, which really blew up over the last 2 years, kind of naturally came together.
And then, Adam, how did you two meet and start working together?
Well, yeah, David actually approached me and then John Chen at Stanford, where we run the Arise network. I come from a very different role. Actually, John Chen at Stanford comes from more of a computer science background. I come from the clinical reasoning background, which is very psychology-focused research on how people, in this case, how physicians or clinicians make decisions. So all of this is all David's doing. He approached me. The impetus of all of this project and thinking about how we can measure harm is all from David. So basically, he dragged me along on this, and this is all because of him.
That's a pretty big statement to make, that it is all you, David. Why don't you tell us about your study and this kind of no harm principle and how that affects generative AI and the large language models that we're using right now?
Yeah, definitely. Well, first, Adam is too kind. I do want to mention for a second, a lot of great ideas and help from Adam and connecting with people. When I first reached out to Adam, he responded immediately. He made the generous effort to get connected and start this whole collaboration. So that was really cool. I think very early on from our discussions, we're all clinicians first, whether Adam, me, Jonathan Chen, and a lot of the folks who work there, including Ethan Go, we're very practical. And when we started developing tools using large language models, a very natural thing kind of occurred to us, which is, how do we know these aren't doing harm? This kind of principle of first do no harm has been in medicine for millennia, and we realized no one else had really measured this, at least not in a scalable or sustainable way, where we have new medical models or new AI models coming out weekly. How do you keep up rather than testing a few examples yourself and manually annotating them? So we realized this was a huge need, and we started brainstorming, how can we measure this in a way to help ourselves pick which AI model should I be using if I'm looking for medical advice, whether that's a patient or a doctor. Can we keep a live leaderboard of this over time so people can see how models are changing over time and which models may be best suitable to them?
So can you tell me, what is this live model? What does it look like? Are you using it now? Tell me a little bit more about that.
Yeah, exactly. So we realize everything in medical AI right now is constrained by evaluation, which is there are models. You can go to chatgpt.com right now and ask a medical question, and it'll give you a very confident and plausible and convincing sounding response. And you might be like, oh my God, it's here. But then how do you know if it's actually good, right? Often we're asking questions that we don't know the answer to, so it's hard for us to verify. So we developed this benchmark, which are real questions that doctors have asked specialists. So we think it reflects real questions that doctors are actually asking. And then we had specialists basically create the perfect answer in an evaluation rubric of what would be harmful for an LLM to say, what would be harmful for a language model to leave out. As you know, missing something is also considered harm. It's not just about saying something actively harmful. So we created this extensive benchmark, and we released the leaderboard results, which we ranked over 30 different large language models. We can give you the link later to send around, but it's based at our Arise Research Network website. And so you can go on there and see which models are doing well and which ones to avoid. right. That's really kind of what we wanted to do, to help people figure out, hey, there are all these models, which one should I use if I want to give safe and accurate medical advice or to help myself in differential diagnosis or management of a patient?
Walk me through the process. You go online. What do you type in? What do you ask? Give an example of like a question and like how it works.
Now I get a nerd out about medical decision making. So believe it or not, it is really hard to know, and I don't know if you would agree with this, David, but it's really hard to know whether or not someone is making a good or a bad decision. There's a lot of contextual factors that go into it. In medicine, in internal medicine and dermatology, we've tended to talk about diagnosis. And diagnosis is very attractive to talk about, and it's very attractive to benchmark models because there's a right answer. One of the reasons the models are really good at diagnosis is that you can reward neural networks by telling them what the right answer is. But David, I imagine this is true for you in dermatology. In medicine, if you watch a TV show, like Dr. House is thinking about the diagnosis like 90% of the time. In the real world, we spend much more time talking about the nuances of what to do and how to do that. And part of the problem is there's so many contextual factors. Like what is the right thing to do is so colored by what else is going on with the patient, how your health system is, what your risk tolerance and risk intolerance is. So one of the really cool things that David did on this work is to create basically a reward system for the models, right? Collecting a systematic way to evaluate whether a management decision is good or bad. And to your question, Yulin, when you look at the leaderboard, effectively what's happening is that for every single possible decision has been evaluated by human evaluators for a gold standard through consensus standards, and it's giving it a score based on what would need to be present and what should not be missing. So every single model is running through that systematically through all the cases in the benchmark.
We test all the common models you've heard of, ChatGPT, Gemini, and Claude, and Grok, and so on. But there's a ton of medical companies that are releasing AI products for clinical decision support now, quite a few. And again, how do you know which one to sign up for and use? Because right now, there is no framework for measuring which ones are harmful, which ones are accurate, and so on. We have a few companies on our leaderboard already who agreed to participate in this study, but over time, we expect a lot more companies to participate with us so that we can have an independent evaluation so doctors and patients can come here and know it's like, hey, this model caused a lot of harm. Maybe I should not be asking it medical advice.
And so how do you keep up with new models coming out and new iterations of it? Are you updating things quite frequently? Also, how do companies get involved? What would be the best solution or best types of partnerships that you would like to see? I'll pitch it to David first.
Yeah, we want this to be useful, so we are trying to keep it very up to date. The day Gemini 3 Pro came out, we ran it overnight and added it to our leaderboard. So we want this to be really useful to people. So a lot of it right now is manual, us keeping our finger on the pulse. But then people who've kind of seen our leaderboard, we have contact information, we have submission agreements and all that on our website and on our GitHub repository. So we want to make this something that's easy for companies who are interested to reach us and get involved. So we're still kind of ironing out some of the kinks because we've gotten a lot more interest than I think we anticipated even in the first few weeks. But we have a good team here kind of building the backend infrastructure. So expect this to be kind of smooth and easy for people who want to work with us.
Adam, do you have any other thoughts?
The other thing that I would say is what we really want to do at Arise is make sure that we're providing important information to clinicians and patients. And one of the challenges, and I don't know how you think about this, David, but we know what doctors are using. We know what sort of commercial technologies are out there that are being used. And a lot of the models on our leaderboard are probably not the ones that are being most frequently used. So one of our hopes is to build this out in a world that it's actually a real reference that somebody can go and look and say, hey, my doctor is using this AI tool. How does it stack up in terms of its use? And one of the things that has really happened in the last year is the amount of doctors using AI, LLMs, as CDS, clinical decision support, has skyrocketed. 2/3 are using it routinely, so weekly or daily, according to a recent survey, which is in line with some of the Elsevier surveys from last year. So this has gone mainstream. This is no longer like academics doing fun experimental tech. This is something that is mainstream that everyone's doctor is pretty much using. And I'm really proud of David and the whole team because this is, in my view, the first systematic way to really look at what this means for making clinical decisions.
Based on all these evaluations you've done, what are the types of errors that you're seeing these AI tools generate the most? And like, what is the hardest to detect?
What we're seeing primarily actually are errors of omission, which means there's something that the AI model should have recommended but did not. It failed to recognize, say, an important lab test or important follow-up, an important medicine that should have been started but did not. And this really surprised me because I think going into this, what we were expecting was that AI models might start saying things like, oh, take this medicine, which might have side effects and actually not be appropriate for the patient. We found far fewer examples of that. And models are actually very good at avoiding these so-called harms of commission. And they were very good at recognizing them. That was the surprise, is that this was driven primarily by harm of omission, which actually mirrors what happens in humans. There are studies of error making in human physicians at scale, and most severe errors are harms of omission, and diagnostic errors certainly often are errors of omission. It's kind of interesting to think that this actually reflects what's happening in humans already. And it kind of led to an interesting approach for mitigating harm, which is what we realized, what do we do as physicians when we think we might be missing something? We often ask for a second opinion. In part of our study and the leaderboard, something we actually looked into was if you paired different AI models together, let's say you take one model and then you ask a second model for a second opinion focused on avoiding harm, would that improve the output and the medical recommendations? And we actually found that was a very powerful strategy for reducing harm and improving accuracy. And we actually took it to a third model. So we asked for a second opinion, then asked for a third opinion, and those were even better. One thing I thought was really interesting, and maybe Adam, you can tell me what you think, is that this only works if you ask different models for the second opinion. If you ask ChatGPT and then ask ChatGPT to give a second opinion, it did about the same. But if you ask ChatGPT and then you ask Gemini or a model from a different company, that tended to be a lot better. So we measured this diversity, which is how many different companies are represented in the team configuration, and found that higher diversity tended to improve the medical advice. I thought that was fascinating and interesting. Until we had this benchmark, we couldn't really prove this or measure this. But I think it has real implications for practical things we can do in real life.
I was less surprised than you, David, and I think it's because of the psychological literature. I cannot stress how weird and crazy this is, because as the models become more advanced, they more mimic the failure points of humans. As David was saying, this is a well-known factor. Humans are much more likely to make errors of omission than errors of commission. And I will say most of that data comes from the diagnostic literature. So like missing little keys that lead to a certain diagnosis. We do know that it's in the management reasoning literature also. And then the same thing, collective intelligence, having different humans with different backgrounds and knowledge levels. And Sylvia Mamid has done some of this research. Really explicitly, it has to be people with different sets of knowledge that they're bringing to the table will improve performance on reasoning tasks. So what we're finding is the same thing we see in humans. And David, one of the things that I'm really excited about is, what about the human AI dyad? We've shown that having different backgrounds of different AI systems improves things. What about when you mix in the different background of a human? How does that change things? So many exciting things in the future. And it really gets to, I think, the power of the team's benchmark, which is these things, maybe they're not surprising to researchers in the field, but I think they are surprising to the companies who are making these. They're surprising to doctors. I think a lot of these findings are unintuitive. Like psychology doesn't often make sense. And it's also, what a cool new field where we're studying human psychology, robot psychology, and how humans and robots work together. And it's just funny to reflect on that.
I think it's fascinating. I do love the point that you have to have other AI systems check AI. You talk about kind of the human AI interaction. How would you go about training then clinicians in the future to kind of then use these systems?
I think this question hits the nail on the head, because what we're doing with this benchmark is understanding how the systems perform independently, tuning them to be safer. The other things that we have to work on is how to get humans to work better with the systems, and then what that interaction itself looks like. We don't know the best way to get humans working well with these systems. In fact, if you look at historical literature, so even going back to the 1970s with like a naive Bayesian system like AAP help, which was to diagnose acute abdomens back in the 70s, we know that the humans usually bring down the performance of models. Even when the model improves them, the model by itself would be better. We know this from other fields as well, like autopilot and airplanes. So there's a well-described phenomenon of a performance paradox where high-performing AI systems will often improve humans, but not to the level of that system operating independently. And there is a paucity of evidence right now in medicine on how you actually improve the humans, not just for cognitive tasks like diagnosis or management, but also procedural tasks, right? They care a lot about this when you're doing endoscopy, looking for polyps, or colonoscopy, looking for polyps with automated polyp detection. So this is a very real question. We have some theories. We're actually running a randomized controlled trial now to try to figure out what teaming strategies work better. But I would say, and David, I'm curious if you would agree with this, right now, this is such a new class of tech. It is such a new human-computer intersection that I don't think there's a good evidence-based answer for how we get humans to work better with the systems.
Yeah, I agree. It's like the generation of people who grew up digital natives. How they interact with technology is completely different from the generation that had not. And we're entering a world where there is a generation of people who are AI native. And, as tech savvy as you and I are, Adam, are we even using these in the optimal way? We don't know. And so I think something really exciting to see the evolution of. Thinking outside of medicine for a second, we're kind of in a phase that almost matches the early 2000s in terms of a different field, chess. At the turn of the millennia, right, we had Deep Blue essentially tied with Garry Kasparov, chess grandmaster of the world. And then it beat it. And that was the headline, which is like Deep Blue beats the world's best chess player. Ever since then, it's kind of been like, oh, well, computers have dominated chess. I will say that in the early 2000s, I think in 2005, there was a really interesting tournament where they had, it could be a computer engine, it could be humans, it could be teams of humans enter this tournament called freestyle chess. And grandmasters were in that tournament, as well as people just running computers. The winning team of that entire tournament, which beat grandmasters and even beat grandmasters using chess engines, were two amateur chess players running 3 different computers. And they were able to achieve the best performance out of any team that entered. And so nowadays, probably the best chess engines will crush any human AI team that you can assemble. But I think in medicine, we're probably in this phase where it's like the early 2000s. There are ways for us to take average physicians and help them achieve basically outstanding performance. And that's kind of the goal. How can we raise the collective performance of physicians? And I expect it's going to come through this teaming approach and clever studies of what makes the right team and how that interface looks. And you don't have to be a medical grandmaster in order to achieve grandmaster performance. I think that's something that should be very exciting for all of us in medicine.
It is remarkable, especially with chess, which still has rules and regulations, right? I think there are issues, though, when it comes to, medicine or even, driving or even aeronautics and piloting a plane. I'll give you an example of we just had a power outage in San Francisco. A third of the city lost power. The Waymos, the self-driving cars, had no idea what to do because that scenario hasn't been programmed in. All the lights are out. They don't understand 4-way stops at that point. They were completely out of order, right? And so you have these situations, and especially where there's so much context to treating a patient. It's not just about this 1 + 1 = 2. There's a lot of other factors. I don't know if AI can do that. And so I kind of worry about this, again, similar to the generation of the digital natives or social media natives. I just learned a term of the Gen Z stare where you can look it up. Someone just showed it to me where they cannot supposedly respond to human kind of interaction. Do you get to the point where you're relying on these kind of AI tools that are you going to start losing the human kind of experience of interacting with a patient and actually understanding those subtle signs and signals that make that type of treatment really truthfully the best that it can possibly be?
We are excited that there are ways to do this where the human and the AI working together will achieve something that couldn't have been done separately. It's something debatable whether that's possible or not. We need studies for that. We definitely don't recommend effectively de-skilling physicians or trainees, or worse than de-skilling, just having them rely on these tools and never actually learn the practice of medicine and becoming competent physicians. That is something we worry about. And Adam has thought a lot about this in AI and medical education. Maybe, Adam, you want to tell us things you've been thinking about?
Yeah, so I think that when we talk about teaming or human-computer collaboration, it's a mistake to think of it as an all or none. I don't know if David would agree with this, so I don't want to put you on the spot. I actually think it's very likely that this idea of diagnosis, the idea of collecting data to figure out what's going on is likely going to be not fully automated, but mostly automated. I think that the Waymo example, obviously Waymo stopping at four-way stops, not the greatest, but I think the Waymo example is probably right for diagnosis because the systems, it's a classification task. Computers are very good at this. Even pre-LLM, differential generators were already quite good. So that is probably going to be a cognitive task that is mostly computers with maybe humans on the loop. For most of everything else that we do, I think there's so much context in making many medical decisions. Like most of what I do requires me physically in the room, collecting information, understanding all of these multimodal inputs. So from a theoretical perspective, I think we're talking about just humans or AI in and on the loop in different ways, in a way that doesn't meaningfully replace the human in any way. I do, to David's point about de-skilling, I think this is a big problem we're having with the way we're rolling out AI right now. We're rolling out these powerful systems, giving it to like young trainees and saying, hey, use open evidence, no one's saying use ChatGPT, but use these systems in a way that when a more experienced physician uses them, they have already built up that skill level that they can provide meaningful oversight. And when you just provide a powerful system to somebody who's still learning, it can prevent getting those skills in the first place. So I'll be honest, I don't know the best way to interact. It is probably going to be different based on the task and based on the level of that trainee. But I'm almost certain that what we're doing right now is not the right thing and could actually lead to a bad outcome for everybody if we don't figure out the right form of human AI teaming. And ultimately, the goal of this is better care for our patients.
One thing I'll say, not to keep harping on the chess example, first of all, people play more chess now than ever, even though you can never beat the computer. And second, I would venture to guess that the average chess player has probably gotten much stronger than before chess engines existed, because now you have a study partner essentially who's always there, seemingly all-knowing, and can essentially be used as a sparring partner or a training partner to elevate your own level. And there's probably a way where we can do this in medical education and in the training of physicians that really raises their level. But the temptation exists, I think, and is very strong, that you just ask the AI everything and suddenly you've essentially outsourced all your critical thinking and clinical reasoning. That is not what we want. I think that is starting to happen in some ways. So we definitely need to kind of turn the ship around.
I think we'll end on that note, because I do really actually like the chess example. You have a stronger opponent. When you have a stronger opponent, then you can technically be at a different level and be better because of it. And it can also be a good teacher. I think that's a positive note to kind of end on, where we can kind of see this as like a really tool to just improve the medical kind of advancements and the medical care. Well, thank you so much for being here. And I look forward to hopefully learning more about this no harm framework.
Thanks so much for having us. It was a blast.
I am Yulin Hswen, Associate Editor at JAMA and JAMA Plus AI. And I've been speaking with Dr. David Wu and Dr. Adam Rodman. You can find more about their no harm framework at bench.arise-ai.org. And for more content like this, please visit our new JAMA Plus AI channel at jamai.org. This episode was produced by Shelley Steffens at the JAMA Network. To follow this and other JAMA Network podcasts, please visit us online at jamanetworkaudio.com or search for JAMA Network wherever you get your podcasts. Thanks for listening.
This content is protected by copyright by the American Medical Association with all rights reserved, including those for text and data mining, AI training, and similar technologies.